In this video, I'm going to talk about the waves vocabulary that you need to know. You should have done the PhET activity in class, and now we're going to look at some vocabulary. So a pulse is a single disturbance that travels through matter or space. So if you're looking at a wave, it's not going to happen over and over. It's just one little bloop. But a wave, in contrast, is bloop, 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 bloop. So then a wave is a rhythmic disturbance or oscillation that travels through matter or space, transferring energy. I also like to think of this as a series of pulses. So it's not just one little pulse, it's a pulse and again and again and again in some kind of pattern. The crest of the wave is the top of the wave. You can think of this like the crest of a bird, the crest of a hill. It's the top. The trough of the wave is the lowest point of the wave. And so I have a picture of horses here because they are drinking out of a horse trough. And so that is showing you, okay, yes, I need to remember the bottom of this wave is like a horse trough. That's where the horses would drink out of. The amplitude of the wave is the height of the wave, but it's not the whole height. You have to measure it from the middle. So you measure it from the middle to the top or from the middle to the bottom. If this was an ocean wave, you'd be measuring where the ocean would be without waves, and then you would measure how tall it got, or from the middle to how low it gets. The wavelength of a wave, you measure how long the wave is. So you would want to measure from crest to crest or from trough to trough. Frequency is the number of waves that go by per second. So this one's a little bit tricky because students often will think of it like wavelength, but it's not the same at all. Frequency is going to be as if you were standing and watching traffic and you're watching cars go by. It's how many cars go by per minute. It's not how big the cars are. Now, if the cars were really, really, really huge, they would have to drive faster for the same number of cars to go by as compared to a whole bunch of tiny little cars. But frequency is specifically how many waves drive by each second. Not how big they are, but how many go by. And then we have to talk about the velocity. So the velocity is how fast the wave is actually moving. So you'll look at one crest of the wave or the top of the wave and watch it move to the right and see how fast the top of the wave is moving. Now, sure, you could pick the bottom of the wave or the middle of the wave, but that just is way harder. So I think of it as just look at the top and follow the top of the wave and see how fast is it going. The medium is the material through which a wave travels. So right now you're listening to me through the air. Therefore, the air itself is the medium that is carrying the sound. Now, sound has to have a medium. If it doesn't, there's no sound that gets transferred. So, for example, if you are an astronaut and you somehow were able to go outside of your spaceship without a space chute and scream, no one would ever hear you. And you would never hear anyone else because sound can't travel through a vacuum. Now, sound can also travel through other things. For example, soup can telephones. The sound travels through the string. If you put your head against a wall, you can hear through the wall. So there's sound traveling through a solid object as well. And in fact, sound travels faster through a solid object than it does through the air. Electromagnetic waves. Now, electromagnetic waves, students often think of as something with electricity, but this is actually not true at all. You need to think of it instead as a different wavelength of light. And depending on the wavelength of light, it'll have more energy or less energy. Now, all the wavelengths of light or electromagnetic waves can go through a medium or it can go through a vacuum. So that's why we're able to see stars from distant galaxies, is because light can still travel even if there's nothing else there. Now, examples include radio waves, gamma rays, microwaves, visible light, UV rays, infrared, X-rays, etc. All of these are a form of a light wave. You just can't see them all. So what I'd like you to do now is watch this video on YouTube.